The Bible called them plagues. Today we call them natural disasters, but they're actually one and the same. And the biblical plagues are coming back. Mosquitoes are born to bite. They swarm by the million, a plague that's described in the Bible. Mosquitoes spread malaria. Every year, 2 million people die of malaria, and the toll is increasing. It's being fought on every front, with medicine, insecticides and technology. But in Africa, malaria remains a big killer, while in Europe, the dangerous tiger mosquito is becoming more common. Who will win, man or the mosquito? Two million people die of malaria every year. In Africa, many people look to God for deliverance. Religion is often the first line of defense against mosquitoes and against malaria. Superstition is rife too. That makes things difficult for scientists trying to fight the disease. Faith was also the issue 3,500 years ago in Egypt. The Bible tells us that the waters of the Nile were undrinkable, and a plague of frogs pursued people into their houses. God visited punishment upon Pharaoh, but he refused to bow to the Israelites. God then spoke through Moses, "If thou wilt not let my people go, behold, I will send swarms of flies upon thee, and upon thy servants, and upon thy people. And the houses of the Egyptians shall be full of swarms of flies." Every grain of dust became a pest. Flies, horseflies, lice, and mosquitoes became a torment for the people of Egypt and their animals.
In the Old Testament, the next plague was a plague of midges, and these midges would have bred very rapidly because they would have lived off the decaying food they had of the fish, the decaying food of the fish, and the decaying frogs. They would have lived off those, and they wouldn't have been eaten because normally the frogs ate the midges, and the frogs had died. What we do know, particularly from Hebrew literature, from the Bible, is that they realized that people could be infectious, and those infectious people had to be isolated. They understood that if someone had a disease, someone else could catch that disease. And I guess this would be observation. You know, if a father in the family got a disease, then this would spread to the children and to the wife. But I don't think they understood that mosquitoes would spread malaria, for example. I don't think they had that understanding.
3,500 years after Moses, Lake Victoria in East Africa. It is not the ideal it appears. Malaria is still one of the principal causes of death on these shores. In Kenya alone, over 50,000 children die of the disease every year. Poverty is widespread. Many Kenyans live without running water in primitive conditions. Hygiene is poor. Mosquitoes are attracted by stagnant water. At night, they and other insects swarm right outside homes. In Africa, a child dies of malaria every 30 seconds. Only female mosquitoes bite. They need blood for their eggs to grow. They inject Plasmodium, the malaria parasite, into the skin along with their saliva. The plasmodium reproduces rapidly in the blood, destroying blood cells. Recurrent bouts of fever weaken the victims until they die. Kenyan researchers know that mosquitoes are particularly attracted to ankles. Why? Is it the smell? To find out, they conduct an unusual experiment. They put some sweaty socks into a trap as a lure. The researchers are from ICIP, the International Centre of Insect Physiology and Ecology, which has its headquarters in Kenya. They've reconstructed a bush hut in a so-called malaria sphere. It's Africa in a greenhouse. Here, the world of the mosquito is laid bare to the researchers. As dusk falls, mosquitoes gather. Drawn by the lights, by the temperature, and by the odour of blood and sweat, they seek out their human victims. The researchers want to learn why some people are bitten more often. What is it in their blood and sweat that makes them a more likely prey? Perhaps the scientists can come up with a deodorant to mask the odours that attract mosquitoes. The following morning, the socks have done their job. The mosquitoes are clearly attracted by sweat, and not just by blood. Now the scientists need to establish just what the mosquitoes find so enticing. Then they can develop an attractant to lure the mosquitoes to their deaths. In some places, improved living conditions have actually contributed to the spread of malaria. Nowadays, rural Kenyans build their houses of brick. Clay is dug up and moulded into bricks. In the last 20 years, more and more small brickworks have sprung up, creating more and more stagnant pools. Standing water is a perfect breeding ground for mosquitoes. The brickmakers' pools are partly responsible for the sharp rise in malaria in the region. Access to water is highly prized in Kenya. In many areas, water for drinking and washing clothes is scarce and expensive. People and mosquitoes vie for the same resources. No one pays any attention to the mosquito larvae in the water. Very few are aware of the link between mosquitoes and malaria. Without human intervention, the mosquitoes will go on multiplying. This has to change, and not just in Africa, but also thousands of kilometres to the north. Germany, the Rhine near Speyer. 80 years ago, people died of malaria here. The marshy riverside is ideal for mosquitoes, but effective medicines wiped malaria out in Germany. The plasmodium parasites were eliminated from the bloodstreams of the population. The chain of transmission from person to person via the mosquito was broken. But we now know that the victory over malaria may not last. Mosquitoes still breed, and they are still potential carriers of the disease. Global warming means warmer, wetter summers, perfect breeding weather for mosquitoes. And tourism to tropical countries could bring the malaria pathogen back to Central Europe. Following heavy rain, Dr. Norbert Becker sets out for the Rhine wetlands. For 20 years, teams of biologists have been monitoring the number of mosquito larvae, and with good reason.
Die Stechmücken waren hier eine Naturkatastrophe. Man konnte sich in den Nachmittagsstunden und Abendstunden kaum mehr in den Gartenanlagen, in Parkanlagen aufhalten. Nicht selten haben mehr als 1000 Mücken einen Spaziergänger hier überfallen. Also die Lebensqualität ist gegen Null gegangen.
If the Rhine rises above a certain point, the banks are flooded, forming pools of stagnant water. This is where the mosquito experts go looking for larvae. In the recent warm summers, the team has had to venture out increasingly often. Uncontrolled, the mosquitoes would multiply dramatically. Early detection makes it possible to limit their numbers. A little further south, beside Lake Lugano in Switzerland, Eleonora Flaccio is hunting an elusive prey, and one that's very hard to spot. She checks the smallest pools of standing water. They are possible breeding sites for a foreign species, the Asian tiger mosquito. This is how the unwelcome immigrants arrive. The larvae travel to southern Europe by ship in old tyres. With rain, they hatch as mosquitoes. Tiger mosquitoes carry tropical diseases like dengue fever and West Nile virus. They have already caused deadly epidemics in the United States and on the island of Réunion. Eleonora is hunting the tiger mosquito together with microbiologist Peter Lutti. The mosquitoes are making their way north from Italy. With the warmer, wetter summers, they can now survive in Central Europe.
È un luogo scuro e assomiglia vagamente ai luoghi originali di sviluppo della zanzara tigre che trovava in Asia, cioè canne di bambù tagliate e buchi nei tronchi d'albero. Grazie al commercio di copertoni usati poi si è espansa in tutto il mondo, insomma dal Giappone è andata negli Stati Uniti, è arrivata in Italia e quindi noi ricerchiamo anche nei depositi di copertoni usati.
As soon as they find larvae, Eleonora and Peter scatter pellets of the poison BTI. It dissolves in water and kills the larvae by destroying the walls of their stomachs. To monitor the spread of the tiger mosquito, Eleonora sets traps. The insects lay their eggs on these wooden slats. Later, she will examine them in the lab. The BTI prevents the larvae from hatching. Nowadays, we rely on scientists to protect us. In biblical times, it was quite different. Were the plagues of those days a punishment from God to be borne without complaint? Mosquitoes had tormented the Egyptians for millennia. They did what they could to protect themselves from the plague of the mosquitoes.
In desert countries, there are all sorts of pests. There are poisonous snakes, there are ants which will bite you, there are these midges which bite you, there are mosquitoes. So there's a wide range of pests. And people, the ancient Egyptians, would have known about these pests and they would have defended themselves as best they could against them. So, you know, with mosquitoes, as we said, they would have covered themselves up with clothing from their necks down to their ankles to protect themselves against mosquito bites, even though it was sunny weather.
Every year, 500 million people contract malaria. The pathogens have become resistant. Many cheap medicines on the shelves for decades are now ineffective. Africa doesn't have the money to develop new treatments. Stefan Bormann, a doctor from Germany, is reluctant to leave the Africans to their fate. He's running a trial program to fight malaria in Kenya. Dr. Bormann's strategy is multi-pronged. It involves killing the mosquitoes and draining their breeding areas, but it's also about helping with information, disease prevention and new drugs. None of these methods has proved very successful on its own. The hope is that a combination of them will be. The details of the daily lives and sicknesses of 30,000 locals are being entered in a database. Dr. Bormann's laboratory is in this modern clinic on the coast. Africa has suffered years of neglect, but now things are finally on the move.
Malaria ist ganz klar eine Erkrankung der armen Länder. Also in den letzten 40 Jahren ist Malaria-Forschung und auch Malaria-Bekämpfung sehr vernachlässigt worden.
But that's changing now. At the Kenya Medical Research Institute, or KEMRI, Bormann's colleagues are collecting thousands of blood samples. They can now monitor the health of the test area. Thanks to modern technology, they can get a quick overview of the situation. If there's an outbreak, they can respond immediately. Malaria pathogens in blood are easy to spot under a microscope. The shape of the cells indicates which stage of the disease the patient has reached. The researchers know their enemy well. Now they only have to find the right weapons to control it. They must be suited to the African context. The first step is to stop the spread of malaria. Stefan Bormann is working together with Charles Mbogo. Dr. Mbogo heads the Mosquito Scouts of Malindi, a town not far from Mombasa. Before every sortie, the Scouts discuss their strategy. These people come from the slums and know the problem well. They set out several times a week, a volunteer force of Mozzie militia, who comb the shanty towns for potential mosquito breeding grounds. That is, for pools of standing water and blocked drains. Breeding sites are marked with GPS coordinates. This field study is unique in Africa.
When we are trying to do this, and what we train the Mosquito Scouts is to inform the municipal council to drain the water. And once the water is drained, then there's no stagnant water being left behind. And after that, then we are happy with the situation.
But all too often, the Kenyan authorities react too slowly, or not at all. Then the Mosquito Scouts get the slum dwellers to take matters into their own hands. No water, no mosquitoes. The slogan is proving effective. Increasingly, people are reporting pools of stagnant water to the Mosquito Scouts. The women especially are getting involved. It's their children who are suffering. They're digging ditches to drain the breeding areas. It's hard work, but it's effective and the first step on the road to curbing the spread of malaria in Africa. But the threat is far from banished. Every day, as clay is excavated for bricks, new pools of water are created. The brickworks are booming as brick houses take the place of straw huts. But at the same time, they are also creating new homes for the mosquitoes. Here too, there's a lot of water to drain. So when the clay has been dug up for brickmaking, all the villagers pitch in. They dig ditches to get rid of the stagnant water, and with it the mosquitoes and the threat of malaria. The larvae can't grow in flowing water. They're flushed away and die. The people here should be less troubled by mosquitoes from now on. Experts from the Insect Institute will come back to check. The drainage has another advantage. What used to be soggy earth becomes arable land. There are fewer mosquitoes and there's more to eat. The children of Lake Victoria once more have a future, provided these measures work and the locals stay vigilant. Cultivating the fields also brings in more money. That's a powerful motivation to keep up the fight against the mosquitoes. The channels must be kept clear so that the water can flow freely. Otherwise, the mosquitoes will be back. Other wetlands are sprayed with the bacterial insecticide BTI, robbing any remaining larvae of the chance to hatch. Kenya is committed to natural insect control. The government has so far refused to use DDT, even though the controversial chemical is being used in neighbouring countries. The Kenyans are concerned about the effect of DDT on public health. Local women sewing mosquito nets. The battle to curb malaria has had the side effect of creating jobs, and there's still a huge need for more nets. Only about a quarter of all Kenyans sleep under mosquito nets, and many of those nets have holes in them. Later, the nets are soaked in a vegetable-based insecticide. New mosquito scouts are taught how to do it. It's important to do it properly because the insecticide needs to soak in. The effect lasts for 5 years. Then the nets must be treated once again. In poor neighbourhoods, mosquito scouts hand the nets out free, especially to women with children. Many people have to be persuaded to use them. They're afraid that the fine mesh of the nets will cause nightmares or trap evil spirits. The scouts demonstrate how to hang the nets properly. Finally, they help people overcome their fears and slip under the net. The scheme seems to be working. The first test results show that using a mosquito net reduces the risk of contracting malaria by 50%. The mosquito scouts also hand out light traps, battery-powered lamps that attract mosquitoes and poison them. Educating the population about malaria is crucial. Where does the disease come from? And what's the link with mosquitoes? Often it's the children who are open to new ideas and ready to abandon the old superstitions. The mosquito scouts use that to spread the message. Kisumu on Lake Victoria, a centre in the campaign against malaria. Here, people are particularly plagued by mosquitoes. Swiss biologist François Omelin leads a project funded by the BioVision Foundation. It too depends on local activists to fight malaria. Omelin has lived here for years. He understands the locals' way of thinking. It makes cooperation a lot easier. At the ICIP Centre in Kisumu, Omelin coordinates all the different measures being used to fight malaria.
The philosophy behind this is really that basically the work is done by the people, by the communities themselves. What is needed is, of course, a certain awareness creation and training of the communities.
The school is full. People have come from miles around. Farmers, fish farm owners and their families. They want to learn more about the causes of malaria. The teachers from ICIP will give them advice on how to eliminate mosquitoes. In the rainy area around Lake Victoria, people are bitten by malarial mosquitoes on average 300 times a year. So they're hugely interested. The lessons are on natural methods of combating malaria and on the biology of mosquitoes. It's the first chance many of them have had to study the insects and larvae up close. The goal is to make the locals work out for themselves how best to master the plague. For the researchers have discovered that the danger lurks less in natural marshland than in man-made pools and rainwater puddles. At the end of the lesson, young fish are released into disused fish breeding pools. When these pools were abandoned, they became perfect breeding grounds for mosquitoes. The local people watch as the waters of the pool get fresh life. The fish need no special care and are easy to breed. A few dozen in every pool will keep the water moving and eat the mosquito larvae. Stefan Bormann is going to visit a bush clinic. These small hospitals are built close to where rural people live. That means shorter journeys and less of a delay before treatment. The patients are given regular checkups. Bormann visits the bush clinics as often as possible. The course of each illness is noted and assessed. In order to understand how the disease spreads, the doctors are monitoring the health of 30,000 people in Kilifi district. In the daytime, the mosquitoes hide beneath the dark roofs of the houses close to the brickworks pools. ICIP staff have come to test how effective their measures are. They're going to spray a plant-based insecticide. Any mosquitoes they kill will fall onto the white sheets. In this enclosed space, the mosquitoes don't stand a chance. The insecticide is a pyrethroid, a fast-working agent derived from chrysanthemums and made in Kenya. It's harmless to humans. The poison takes 10 minutes to work. It's important that the children get the message that something can be done about mosquitoes. The buzzing has stopped. Time to collect the catch. In front of everyone, the mosquitoes are counted. The insect experts check each cloth in turn. Their trained eye quickly tells them which species of mosquito they have poisoned. Here, close by the brickworks, the number of mosquitoes has been dropping year by year, a measure of their success. The task is not much different in Europe. In Switzerland, Eleonora Flaccio and Professor Luti are looking for evidence of the tiger mosquito's advance northward. Eleonora makes regular checks of the slats from her hundreds of mosquito traps, and she regularly finds eggs from the disease-bearing species of mosquito. The mosquitoes lay the eggs on the part of the slat that sticks out of the water. Every year, the number of eggs doubles. No doubt about it. These oval eggs are Aedes albopictus, the tiger mosquito, so called because of its striped abdomen. Some of these eggs will be hatched in the lab. Eleonora wants to make sure that these are indeed tiger mosquitoes. Strict precautions are in force. No one wants to release mature mosquitoes. The larvae need 20 days at a constant temperature to turn into pupae and then into adult insects. Mosquitoes like long spells of warm, damp weather, conditions which, thanks to climate change, are now found in Central Europe. Professor Liuti has found an adult tiger mosquito in the bushes near a motorway service station in South Tessin. How many more are out there? He has to act fast because these mosquitoes can transmit deadly viruses. There's another way that tiger mosquitoes enter Europe. Their eggs have been found in the roots of imported bamboo plants. Adult tiger mosquitoes have been found in the port of Rotterdam in the Netherlands. Bamboo came on the market as a bringer of good luck. Ironically, it may turn out to be bringing an invasion of mosquitoes. The scientists have mapped the locations where tiger mosquitoes have been found. They first appeared in Tessin in southern Switzerland in 2003. Mosquitoes are poor flyers, and under their own power they travel at most 200 meters from where they hatch. So how do they spread? The answer is obvious. They travel through Italy by motorway. They're transported to new areas as stowaways in cars and trucks. Liuti and local canton officials swing into action. An early morning spraying session at the motorway service station. It might seem like a lot of effort just to kill a few insects. And no one knows how long their work can stop the mosquito from spreading throughout Switzerland into Germany. But Liuti is not prepared to give up yet.
Ich hoffe, dass wir den Kampf gewinnen. Und wenn wir den Kampf nicht gewinnen sollten, haben wir insbesondere sehr gute Informationen über das Verhalten der Tigermücke.
The fight against the tiger mosquito in Europe has only just begun. Germany is also taking action. Following heavy rain, the Rhine is rising. The mosquitoes are breeding fast. Within days, they could hatch in immense numbers. Norbert Becker's colleagues are pouring tons of BTI pellets into a hopper. Every year they have to do this more and more frequently. Similar to a high-tech military operation, it's the fruit of 20 years' experience combating the insects. The pilot is heading for the floodlands. There he will drop the poison. The BTI is scattered over the wetlands along the Rhine. Within hours, most of the larvae are dead. This time, the mosquito invasion has been averted. But the danger has not been banished. Temperatures are on the rise, and if tourists bring the malaria pathogen back home with them, the disease could break out on the Rhine once again. Human beings have fought insects since time immemorial. But now the mosquitoes are colonizing new territories and the pathogens are mutating. The humans are responding with advances in medicine. It's an accelerating arms race.
The ancient Egyptians, they had their own doctors, and so it was natural herbal medicines, and I think we just don't know how effective they were. I think you can look to China, where China has had these ancient Chinese medicines which have existed and propagated down for thousands of years. So the Chinese medicines used today were used thousands of years ago, and many of those are very effective. And we're just learning about that in the West. So maybe the Egyptians have very effective herbal remedies as well.
Africans have their own solutions. They use the leaves of the neem tree. It grows in every village. They call it the tree of 40 cures. It has no prophylactic effect and it can't stop the spread of malaria, but an infusion of its leaves eases the symptoms of the patient. Most patients in Kenya can't afford expensive medicines, so the hospitals fill up, particularly after the rainy season. Children under 5 have the least resistance and suffer the most. Despite their best efforts, Stefan Bormann's medical teams must live with setbacks. Some mothers simply come too late because of the long walk to the municipal hospitals. At the pharmacies, there are long queues. The cheap medicines are losing their potency. The mosquitoes and the pathogens have built up resistance. There's a pressing need for a solution. Researchers are working flat out. At the ISIP laboratory beside Lake Victoria, the British scientist Annabel Howard is trying to find a cheap, effective medicine. She is breeding malaria-free mosquitoes. She needs the mosquitoes in order to breed larvae, but to do this, she must feed the females blood. In this case, it's horse's blood. The mosquitoes don't like it very much, but they are hungry. And as long as the blood is warm. Each mosquito must pierce this membrane with its proboscis. To suck blood, a mosquito needs some resistance. It's a simple method and saves the test animals from a nasty sting. The females are attracted by the scent of the warm blood, and they tuck in. The blood flows into their bodies. Soon they will lay their eggs. The blood pulsates through their abdomens. Annabel is about to douse the newly laid larvae with different concentrations of an extract from the leaves and bark of the neem tree. She has no idea what effect it will have. Usually, neem is given to the sick as a medicine. The results are impressive. The higher the dose, the more powerful the effect. The larvae slowly stop moving and die. A discovery that's soon acted upon. The locals begin to shred neem leaves and branches. This tree of 40 cures grows everywhere in Kenya. It promises hope in the battle against malaria. Every part of the tree is used. The dried leaves are pounded. The neem shavings are dried in the sun and then packed. Meanwhile, the bark is to be used in a field study. Assistants place the bark shavings in old brickworks pools and empty fish breeding ponds. No one knows how much is necessary, so for now the motto is the more the merrier. Slowly but surely the neem is leached of its active ingredients. Will the larvae die as they did in the lab? Two weeks later, the assistants trawl the pool. They don't find any larvae, but they do find other predatory insects. The larvae's natural enemies have survived the assault of the neem bark. It's a wonderful example of how malaria can be fought with the simplest of means.
They are really extremely pleased and excited. They are even grateful because in certain areas they have observed themselves that they have less mosquitoes and less malaria. So the success of their own success and their own ownership over the project is a very critical point in any approach.
Francois and Annabelle have scored some early successes, but the search for new methods must go on. In the ICIP labs, researchers have found a new ally in the fight against mosquitoes. A jumping spider. Its giant eyes can seek out anything that is red. It too needs blood to survive. The spider ignores male mosquitoes. But if a scientist introduces a female full of blood, the spider quickly responds. The mosquito's red abdomen sends a powerful signal. The mosquito has no idea it's being stalked. The killer spider sneaks up on the female while she is resting. The spider pounces on its victim and sucks the blood. In Africa, these spiders often shelter inside houses. Tests suggest that fewer mosquitoes survive in homes where there are also spiders. It's not yet clear how the spider's potential can be harnessed, but there are still more bioweapons. The tiny robber fly. It targets the larvae of the Anopheles mosquito by sitting on the edge of a pool and awaiting its victim. Each robber fly can eat several larvae per day. Robber flies are common and could be bred and released into mosquito breeding areas. The research is at an early stage, but it is advancing rapidly. This is Artemisia annua, or sweet wormwood. The leaves of this fast-growing plant contain a substance that combats malaria. Artemisia drugs kill the pathogens in the bodies of malaria patients. Kenyan farmers are investing in Artemisia. The number of Artemisia fields is growing rapidly. But the infrastructure isn't yet in place. The crop must be processed in makeshift factories. The Kenyan government is committed to using Artemisia as a follow-up treatment for patients. So far, the malaria pathogen has shown no resistance to Artemisia. It has only one disadvantage: it is too expensive for a country in which most people earn around $1 a day. Production is going full speed ahead. Artemisia's effectiveness in the treatment of children is being studied on the Kenyan coast. Stefan Bormann's medical teams make regular trips to the bush clinics.
No cyanosis, no edema, and he was febrile with a temperature of 36.6 degrees centigrade.
For Dr. Bormann, swift local medical attention is the key. Treating malaria is a race against time. If the infection is identified quickly, there's every chance of successful treatment. The children Dr. Bormann is treating here all have malaria. Their parents have agreed to let them take part in a test. The children have been given a course of a new medicine, artemisinin. To minimize any risk, they're trialing it only with mild cases. The children take the medicine in the form of a juice. So far, the results have been positive. The children's condition has improved rapidly, and they're soon allowed home. The hospitals are emptying. Just outside Nairobi, there's a unique national park with savanna and wild animals. But this is also the location of a project that could bring hope to thousands of malaria patients. Engineers and chemists from a Swiss pharmaceutical company are building a giant laboratory. This is where they will turn the weed Artemisia into the medicine artemisinin. The pills made here will be exported to all of East Africa, creating many more jobs. More and more farmers are cultivating Artemisia. The factory currently employs construction workers, and soon it will need technicians to dry, extract and distill the artemisinin. The price of the relatively expensive drug may then come down. Kenya is staking a lot on artemisinin. Even as tests continue in the provinces, the government is taking out big advertisements in the newspapers to promote the new medicine. The children treated with artemisinin are regularly checked by Stefan Bormann's team. So far, there have been no problems. But the doctors know there is no such thing as a miracle cure. Only if all the different measures are used together and a whole population changes its behavior do they have a chance to control malaria for good. The first results are encouraging.
Es ist so, dass wir seit über einem Jahr weniger Malariafälle in Kilifi-Distrikt sehen. Wir wissen immer noch nicht, ob es damit zusammenhängt, dass die Malaria-Transmission, die Übertragung der Malaria von der Mücke auf den Menschen halt zurückgegangen ist. Es kann damit zusammenhängen, dass es weniger Regen gibt in dem Gebiet. Aber wir denken auch, dass unsere eigene Arbeit dazu beigetragen hat.
Life outside the cities and the tourist areas is slowly changing. Here in Kilifi, a start has been made, thanks to the work of Stefan Bormann and his team. People know more about mosquitoes and how to protect themselves against them, and they seek medical help more readily. But a lot of work is still needed to avert the threat mosquitoes pose in Kenya. Mosquitoes are moving into areas where they've never been seen before. Malaria is coming to the Alps, one result of global warming. It's a new challenge for scientists. They may never entirely win the battle against the mosquito. To the ancient Egyptians, the plague of insects was a warning. It was the finger of God pointing at them. Today, malaria affects the poor in tropical regions who have little access to modern medicine. Tomorrow it could affect everyone, because we are all threatened by new plagues.
What we do know now is that things like bird flu can exist, global warming can exist, malaria can exist, and it's our duty to do what we can to minimize this and to make the world a better place for our children and for our grandchildren. We have that responsibility and we have that duty to do this.
The Bible says, "The Lord removed the swarms of flies from Pharaoh, from his servants and from his people. There remained not one. And Pharaoh hardened his heart at this time also, neither would he let the people go." A new plague threatened as the punishment of God.